Good day, students. Today I want to solve a problem involving differentiation with the use of first principle, the very simple method. Please listen attentively. Students find it difficult in solving because they don't follow the normal rules of solving it. Now, when you are solving this, you have to know this method. When before we put one, that one, we now separate it, 1, 1. And add it together, 1 plus 1, 2. Still bring 1 side to it. 1 plus 2, 3. 2 plus 1, 3, 1. You always think 1, 1, 1. You bring another 1 here. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4, 1. When you have it squared, you use the second line. If you have cube, you use the third line. When you have English for 4, you use the fourth line. Now, in this case, we are going to use the second line because we are having squared. And we use this first one because we are having x. So for x raised to power 1, we use this one for this. Okay, you will see the way I will apply it. And when you are differentiating this with first principle, you can first of all use this method, general method. Y equals to ax raised by n minus 1. Now, having y equals to ax raised by n. Differentiate it, dy over dx equals a multiply the n will come to the front, x raised by n minus 1. Now let's apply it for this. Dy over dx equals 3 times 2, x raised by 2 minus 1 minus 4 times there's 1 here, 1 x power 1 minus 1. Division of constant is 0. 3 times 2, that's 6 x, 2 minus 1, that is 1. That is 6 x raised power 1 minus 4 times 1, 4. X raised power 1 minus 1 is 0 plus 0. Because 6 x over 1 is x minus 4 times x over 0 is 1. Anything raised by 0 is 1. Plus 0 equal to 6x minus 4. When we are differentiating the general method, we have 6x minus 4 dy over dx equals to 6x minus 4. Now, let's use first principle to differentiate this. Now, when you have a change in y, you must have change in s. Likewise, what do you mean by that? Is y-axis and this x-axis. As you have a change in y, you must have corresponding change in x. Likewise, that's what we are going to do here. Y plus change in y equals 3. 3 is common to all. Open the bracket, x plus change in x squared. As you have change in y, you must have change also in x, corresponding change in x. Okay, and since you have a squared here, you have x plus change in x squared minus 4 into x plus change in x. There's no square here, you know square it plus 5. That clear? I will show you when to apply this. Since you have it squared and the one that doesn't have square, that's ordinary x, you use this and this for this and this for the second one. Okay, now can you see I'm using delta y because we are starting with a change. But if you get to a point, we are going to change to dy over dx when dx tends to 0. But we have not gotten to that point. Take y to the other side, but we're looking for dy over dx. Now change in y equals 3 into x plus dx squared minus 4 into x plus dx plus 5 minus y. When it causes y causes the cos sign, change to negative. Dy equals 3 into x. Now here, you have to do something. You have to take note that as x is decreasing, dx starts increasing when you are putting this value into it. Now you have x. You can see you have x here. To carry the square here, x squared. Are you seeing it? Dx will be here. Dx raised power is 0. You see that the first thing 2 for x, dx is 0. As x is decreasing, dx will start increasing. Like now, this one, there's 1 here, but you don't need to put it. Okay, now start with the second one plus these 2. We introduce it, 2, x will decrease, 2x, dx will now go up. You see that from x is from 2 to 1, the power from 2 to 1, dx now go from 0 to 1. Dx raised power 1. Is that okay? But you don't need to put it, just put dx. Followed by the next one. This x now will disappear, plus dx squared. See that it's 1. We have introduced 1 to 1. 1 to 1. Okay? Close the bracket. Minus 4 into x plus dx plus 5 minus 6. What you have at the right hand side is in terms of x. You now replace your y with what you have here, expression for y, minus 3x squared minus 4x plus 5. Is that okay? Now let's use this 3 because it's common to x squared. Now open the bracket. The y equals this x raised by 0, dx raised by 0 is 1. You don't need to repeat it again. 3x squared plus 6, 3 times 2, 6x dx. Because multiplication is we only multiply this number, plus 3 times dx squared, 6 dx squared minus 4x minus 4x minus negative 4 times positive dx is minus 4 dx plus 5 minus 3x squared minus 4x minus 3x squared plus negative and negative as positive plus 4x negative times positive as minus 5. This cancel this, plus 4x cancel minus 4x, minus 3x squared cancel 3x squared. The y now equals 6x dx plus 6 dx squared minus 4 dx. Now let's factorize dx out. The y equals 6x plus 6 1 dx minus 4 bracket dx. We have factorized dx out now. Since we have factorized dx, because we look for what is common in all, which is dx, divide both sides by dx. Okay, let me write it. Divide both sides by dx. Now dx over, sorry, dy, having dy over dx equals 6x plus 6 dx minus 4 dx divided by dx cancel dx, having dy over dx equals 6x plus 6 dx dx minus 4. Now limit as dx tends to 0 of dy of dy dx. That is, anywhere you have dx, you replace it with 0. We have 6x plus 6 into 0 minus 4. Now, when you say limit as dx tends to 0, you now change this delta to small letter d, dy over dx equals 6x, 6 times 0 is 0, 6x minus 4, which is what we have here, 6x minus 4. This is what we call first principle, using first principle to solve differentiation. Okay, this is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.